Alright, so let's get started. This is section 5.5, your double angle identities. We'll start off by showing some of the derivations for your identities. Alright, so all of these are going to be based off of your sum identities. Okay, so for our sum identities, we'll put that guy up there. Your sum, S-U-M, identities, when you take something like cosine of A plus B, like when you're taking the sum of two angles. So if we look first, look at cosine as an example. If we look at our identity, cosine of A plus B, we get our identity is cosine of A, cosine of B, remember to change the sign, minus sine of A, sine of B. Now, to get our double angle identity, and you do this to derive all of these different theorem or identities here, is we're going to take, instead of cosine of A plus B, take cosine of A plus A, because that is equal to cosine of 2A, which is what we're trying to find. So instead of plugging in B, we plug it in A, so we get cosine of A minus sine A, sine A, which is equal to cosine squared A minus sine squared A. Alright, so that's the basic derivation, but we also are going to get two different other ones for cosine. If we replace cosine squared with 1 minus sine squared of A based on a theorem, or if we replace minus sine squared with 1 minus cosine squared of A, and you'll see these two different theorems up here, or other identities right there. Alright, and then to find your double angle of sine, do the same thing, and for tangent, you're going to use your sum theorem as well. And just to recall those theorems, so sine of A plus B is equal to sine A cosine A plus sine B cosine B. Alright, and your tangent of A plus B, to derive your formula from it, is equal to tangent of A plus tangent of B over 1 minus tangent of A tangent B. Alright, so let's look at our first example. So in example 1, and it's very frustrating to me that it does this, alright, is that we're given cosine of 3/5, and we know that sine is going to be negative. Okay, so that tells me that if sine is less than 0, that it's going to be in quadrant 3 or quadrant 4. Alright, we need to find these three identities here. Okay, so if we go back and look at our angle identities that we have, we notice that to find sine of 2 theta, alright, so for our sine of 2 theta identity, which is going to be is equal to 2 sine theta cosine theta, okay, we need to know what sine is, okay, we need to know what sine is. Now there are two different ways to go about, that looks awful, sorry guys. There we go. Two ways to go about finding sine. First way is how they do it here. Okay, they use the fact that this identity is our Pythagorean identity. Okay, we know that sine squared of theta plus cosine squared of theta is equal to 1, and then they rearranged it. Alright, and they subtracted cosine theta, so they got sine, and then they just plugged in their values. But what you can also do is you can look at it and you can say, let's look at this as a triangle. Okay, now we know that it's going to be in quadrant 3 or 4 because sine is less than 0. Now we also know that because cosine is positive, it has to be in quadrant 4 now, because cosine is negative in quadrant 3. Okay, so we can draw our triangle here, and we know that, and this is our theta, that cosine, which is adjacent, is 3 over hypotenuse over 5, and shortcut, we know this is a 3, 4, 5 triangle, so we get that it's negative 4. But you can also use the Pythagorean theorem to find it. So you'd say 3 squared plus y squared equals 5 squared. And you solve and get that y squared is equal to 25 minus 9, which is equal to 16. So take the square root, and since we're in this quadrant, we know that y is going to be equal to negative 4. Alright, so now we can find all of our different identities that we need, because we know that sine of theta is equal to opposite of, so negative 4 over our hypotenuse over 5. Okay, so we find that sine of 2 theta is equal to 2 sine theta cosine theta, which is going to be equal to 2 times sine theta, which is negative 4/5, cosine theta, which we're given from the beginning, 3/5. So then I like to think of this as over 1. So we multiply the numerators. So we'd have 2 times 4 is 8 times 3 is 24. So negative 24 over 5 times 5 is 25. Alright, and then we can find our, which you see what they got right up here. Yay. And get cosine of 2 theta, which is equal to cosine squared of theta plus, or sorry, minus sine squared theta, which is going to be equal to cosine squared, so 3/5 squared, minus sine, so negative 4/5 squared, which is equal to, and there's actually a little typo up here, it's supposed to be a minus in there, so which is equal to 16. Oops, can you guys see that? Which is equal to 16/25 minus, 9/25 minus, so it's equal to 9/25 minus 16/25, which is equal to negative 7/25, which is what they got right up here as well. Okay, so then we need to still, we found sine of 2 theta and cosine of 2 theta. Now we just need tangent. Alright, so we just need to now find our tangent of 2 theta. Alright, so we're using our equation here. Now if we remember our triangle, we can easily find theta. Okay, so we had negative 4, 3, and 5, because it's a 3, 4, 5 triangle. And so we know that tangent of theta is equal to opposite over adjacent. Alright, so if we plug in our values, so tangent of 2 theta is equal to 2 times tangent of theta, 2 times negative 4 over 3, divided by 1 minus tangent squared. Okay, so negative 4/3 squared, we get, think of it over 1, so negative 8/3 divided by 1 minus 16/9, which if you think of this 1 as 9/9, so that'd be 9/9 minus 16/9, you get that it's equal to 8/3 over negative 7/9, which is the same thing as negative 8/3 times 9/7, which is going to be equal to, these divide into just 3, so it would be equal to 8 times 3 is 24 sevenths. So there's actually an error up here. Now there's another way that you can find this value, and I'll show you that on the next page. So you see that that was an error on the last page, because in this case the answer here is 24 sevenths as well. So you can use a different, you can use your quotient identity instead, because we know that tangent of theta is equal to sine of theta over cosine of theta. Okay, so you're just replacing that using the double angle identities, and you put in what you found at the beginning, which, so this we got on the first page, and this we also got on the first page, and then it simplifies to 24 sevenths.